Science 24s, what you're going to need to do for this unit is actually do a science lab at home, a chemistry lab actually. And so in that chemistry lab, you're going to need to use some equipment, you're going to need to ask some questions about how chemistry works in your life, and you're going to need to maybe make something. This should not take more than a couple dollars worth of materials. If you're having any trouble getting materials, you're more than welcome to come into Outreach and I will get the materials for you. If you are not able to come into Outreach because you don't live in Spruce Grove or in Stony Plain, I can also perform the experiment for you on camera and then you can do the analysis afterwards. So if there is any trouble with you doing this experiment, just let me know and we will figure out a way for this experiment to happen. So first of all, here's some options for what you can do. You can look at farm chemistry, which is one of the topics we're going to be talking about. This could be we're looking at different fertilizers, watering plants on different days. The only problem that I can see with this assignment is that it's going to take a long time. So you could do like which beans sprout fastest, whether you put them in water, coffee, or pop, and try to see which plants start, but you're still going to have this time factor in there, which is completely fine, but that's why we're watching this video first, because then you could start your experiment right away. If you want to look at food chemistry instead, this one I think would be the most fun. You don't have to do it, but this one I think would be fairly simple. You're going to take a recipe, your favorite recipe, whichever one you like the most, but then you're going to change something. So you're going to make either 3 different batches or one batch split into 3 parts. And then you're going to change something. How much sugar you put in, how much baking powder you put in, how much flour you put in, whether you use eggs or whether you use vinegar, because vinegar is an alternative to eggs. All of these things are different ways that you can actually experiment with food chemistry. So this would be one where you're actually getting to eat the results, which is kind of cool and a good way to actually look at your overall results. But you're going to have to cook something. Again, I'll go over how you need to measure and all of that stuff coming up. But food chemistry is another fairly simple, easy option. The next one is everyone's favorite, reaction lab chemistry. So this would be like taking baking powder and vinegar and putting a certain amount into a Ziploc bag, closing it up, watching that reaction happen, and then seeing if it bursts the bag. Super fun, but still needs to be done as an experiment. So if you're going to do this one, make sure that you're doing it as an experiment, not just as a, I want to blow up the bag. The other one, making Mentos. Mentos is also one where you're going to need to do it as an experiment. So Mentos and Diet Coke, amazing reaction, super fun to do. Personally, I love doing it all the time. I do it every summer. But to make it actually have a really good reaction, you need to think about how you could measure that. So are you going to be measuring how high it shoots up? Are you going to be measuring how much Coke is left in the bottle? These are really important things to think about before you do the lab. If you have any questions on this, send me a message and we can set up your lab together. Polymers is kind of the last one I've put here. This would be like making slime. A lot of people like to make slime. If you're going to make slime, how do you make it the best? What's the best recipe? So this could be another sort of similar to our food chemistry where you're making the same recipe, but you're changing one of the ingredients to see if it affects how the slime is made. If you don't like any of my ideas and you have a really great idea of your own, let me know. I'm happy to make that work for you. We just need to make sure it's going to be set up as a proper lab. So when you hand in your lab, you're going to need to have the following things. You need to have the problem, which, if you're choosing one from above, might already be given for you. Variables, data, you need to analyze that data, and then you need to have a conclusion. So I'm just going to go quickly through what each one of those things means. So your problem is basically, what are you looking for? How many Mentos uses the most amount of Coke? Then you need to have your variables. Now, the variables are going to be the most important part because this is what determines what's going to happen in your lab. So you need to have a manipulated variable, a responding variable, and then multiple controlled variables. Your controlled variables means that everything that you aren't changing or measuring stays the same. It's really important. So let's start with manipulated. Manipulated variables is what are you changing? So in your lab, I need to have at least 3, but no more than 5 different trials. So for your 3 trials, if, for example, you were doing food chemistry, you would need to have the regular amount of whichever ingredient you're changing, a little bit more, and a little bit less. And when I say a little bit, that amount is up to you. But you should have the same amount more and the same amount less. So it has to be something you can measure. It has to be a number. You can't just say, this will be okay. If you are doing food chemistry and you want to try different, for example, different flours, you could use that as your thing that you change, and then you wouldn't necessarily be measuring it, but you would be using different flours. And what I mean by that is like all-purpose flour, coconut flour, you could have whole wheat flour, and check those differences on your recipe and see if they change. Maybe the consistency would be the easiest thing to test for that one. But most of the time it's going to be a number. How much Coke is left in the bottle if I use 3 Mentos, if I use 5 Mentos, if I use 1 Mentos. And then you've got something that you can measure after. So you want to be able to give a number, 99% of the time, a number for your manipulated variable, and then a number for your responding variable. Your responding variable is going to be what you measure. So when you're measuring it, you're going to need to be able to use a ruler. You're going to need, for example, with your Mentos, you might be measuring the height of Coke left inside the bottle. If you're doing slime, you could be like how much you're able to stretch it before it breaks. In the food one, you might actually have to do qualitative over quantitative. Quantitative means a number. Qualitative means comparing the quality. So you might have dough or muffins. If you use different types of flours, the muffins might stay together better with a certain type of flour. So that's an option there. When you go to your controls, you're controlling everything else. So if you're doing a recipe, you're going to make the same recipe, everything exactly the same, cook it in the same oven at the same amount of time for all of the trials. So everything stays the same. If you're doing the Coke and Mentos, you might do it on the same day, in the same place, because if you did it on a rainy day or on a really hot day, you might have a different result than on the same day. You're going to need to control things like temperature, length of time, all of those outside factors. You may not need to control like what type of materials you have. For example, if you're cooking, you may not have 4 of the exact same bowls, but you can put them in a different bowl and it's not really going to make a difference. So that for control is more like what's going to react, what's going to affect that reaction. You want to keep everything the same except for the one thing that you're manipulating, changing, and then what's going to happen after you've changed that. So those are your variables. I spend a lot of time on that because I think it's the most important. Your procedure is going to be step by step what you're going to do. You can include video and pictures for this, but I need to see what you're doing. If you don't want to do video, I need to see pictures so I can see each step along the way. Your data, you're going to make a data table, and there'll be one in here to help you. So your data table will be what you manipulated, and then the different numbers, and what you ended up measuring as your results. That's what you're going to have in there. Your analysis is going to be what happened. Did you expect it to happen? Explaining to me what happened in your experiment. In your conclusion, you're going to give a short summary of the experiment, like 3 sentences. What were you testing? How did you test it? What did you learn? And then you're going to give me what might have went wrong and what you'd do differently next time. And last but not least, what would your next question be in this testing? Our conclusion is going to be just as important as choosing our proper variables because it's the last thing we read and explains everything that happened in the experiment. So make sure you have a good conclusion. Now I want to emphasize this. You are allowed and encouraged to talk to your teacher about this experiment before you do it. When you start this unit, you should be emailing your teacher saying, I'm thinking about doing this type of experiment. Do you think it's a good one? Or, I would really like to try this experiment, but I'm a little bit confused on what I could do for the variables. Please, 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 email your teacher, ask questions. That will get you the best result.